All right, did my screen come through?
Yes.
Thank you. Yeah, compared to Total Precision, I think our assessment and our use case was a little bit more on the technical side. So we LCM had to assess a company called Salvagnini Maschinenbau GmbH. Both we are situated in Austria, in Upper Austria and Lower Austria. So I will quickly go through the agenda. So I would like to introduce the Linz Center of Mechatronics, Digital Innovation Hub, as well as the company, and talk about their motivation to join the assessment. Then I will talk about the assessment process and the key findings, the recipe we established based on the assessment results, and then quickly summarize with the next steps and the lessons learned. So Linz Center of Mechatronics is a research and development service provider situated in Upper Austria on the university campus. We have around 120 employees, 300 customers, and we have 4 areas focusing on research and development in the hydraulic and electrical drive sector, in sensors and communication, in mechanics and control. This is the area where I'm from. And we have one area about future and emerging technologies. We also host a government-funded research center, a competence center on symbiotic mechatronics, where we do more fundamental research with different university institutes and company partners. The company we assessed was Salvagnini Maschinenbau GmbH. They're also situated in Austria, about 30 minutes away from LCM. They are a competence center for automized bending solutions, and they have a manufacturing plant for automatic bending centers here in Austria, in Ensdorf. They have around 450 employees, and their turnover 2021 amounted to 139 million euros. So their portfolio consists out of automatic bending centers. So at the top of the slide, you can see a smaller bending center, the P1, and at the bottom, you can see also a larger bending center, complete bending center line, where you can automatically manufacture from one metal sheet in one automized way, complete full sheet metal product. For those who do not know automatic bending centers, I just quickly want to show a video where you can see a sheet being automatically inserted and being bended to a final product. And key for precise products is to have a proper toolpath planning and to also consider differences in material properties as well as machine deformations. So for this reason, the company Salvanini Maschinenbau has actually already acquired a very high level of digitalization and automation. So we graded them at a level 4 to 5 at the ECATEC Maturity Index. Here we have to mention that this was based on their product. So when we talk about digital twins, in the case of Salvanini, we always see these digital twins of their products, of the panel bending system, which was a little bit hard in the assessment when it comes to assessing the impact or assessing the benefit of digital twins, because their product was actually the manufacturing machine. So Salvanini has already developed together with LCM a digital twin for toolpath planning and for automatic correction of material deviations years ago. And they also have a very strong vision on something they call social industry, where they see in future that cyber-physical systems and digital technologies collaborate closely together to get plants more effective and working conditions better while respecting also the environment. So they have a very clear vision towards high levels of automation and digitalization for the future. The motivation to participate in the assessment for Salvanini was that they were interested to apply a very structured framework and to get a fresh, holistic view on the digital twin perspective, and here with a focus on business needs. So the presentations they have seen so far from the Change2Twin pointed in this direction, and we will also see at the end that actually we could get out quite a lot from this assessment and from this very structured framework for assessing digital twin potentials. So the assessment with Salvanini was based on different workshops and a lot of telcos where we went through the compass tool, the readiness tool. I will not talk too much here about the marketplace because we could not find solutions which perfectly fit the needs of Salvanini. Then the recipe generation and what also took a lot of time was actually the generation of the assessment report, which was of course also one essential ingredient of the project. So we started the assessment with initial emails and telcos with Salvanini, where we prepared them for our first workshop, which was face-to-face at the Salvagnini factory. It lasted around 4 hours, and here we filled out the compass tool and talked a lot about the business impact and the why. After that, we post-processed all the results. We finalized the compass tool and prepared a summary for Salvanini, which we presented then at the second workshop, where we, together with the company, worked on the digital twin readiness tool, also again for 4 hours at the Salvagnini plant. And again, after that, we had quite some time for post-processing, finalizing the readiness tool and for a summary again. And based on all these results in telcos, we actually created together with Salvanini 3 recipes and a conclusion. And then we generated the assessment report, where all in all, we spent from the DIH around 80 hours for this project. And as already mentioned, also the assessment report took quite some time to perform. So what was the key findings during the assessment phase? So the compass tool was very helpful for us because in the past we always or most of the time had very specific technical ideas which are realizable and based our digital twin developments in this view. And the Change2Twin compass tool actually reminded us on the why and put everything into perspective of business ambitions. And this helped us a lot for getting really a fresh view on digital twin development. And in course of the compass tool, we also identified the total cost of ownership at the customers was actually key for Salvanini to reach their strategic future goals. In the readiness assessment, we found very helpful the readiness gap analysis, which came out as a result. So we had some idea where we stand, but here we could then really pinpoint where we are good and where Salvanini has to do some work to achieve better. We saw from this readiness assessment that Salvanini was in an excellent position to implement the digital twin solutions they envisioned, since all the required IoT infrastructure is already in place. They already have a digital twin core model, which works and just has to be adapted. And we also saw that cradle to grave was the point where they could improve with the specific details that judging the digital twin fitness, detecting changes, and also maintaining the digital twin alive over the whole life cycle was something which was not so present before the assessment. So from the assessment results, we together created one recipe. This recipe went in the direction of preventive maintenance. It should suit the overall purpose to decrease the total costs of ownership at Salvanini's customers. The asset was their panel bending center, and we wanted to achieve this goal by using a mechanistic remaining useful life prediction of these panel benders. And what we have to do for that is, since all the infrastructure is already in place, we have to somehow adapt the digital twin core model of this machine to compute the loading and the wear of the different components quasi real-time, record that, and create a prediction model for remaining useful life on the basis of machine loading. So not only an anomaly detection, but really prediction of remaining useful life. What also went clear here is, again, that we have to take special care about digital twin fitness and maintenance of the digital twin. And for this reason, we also suggested in the recipe to first, after evaluation on a prototype machine, also use this digital twin first in a shadow mode, then use it as a decision support system to really quantify the performance of the digital twin, and then after quite some time, use it in fully automatic mode for an optimized for an optimized alert of service team when we see that machine parts start to degrade. What we also want to do here is that we want to use the data which is generated in the field to also improve this digital twin over time and to achieve better predictions with all the newly generated data. So what are the next steps and what have we learned in this assessment? So the next step was that Salvagnini took this recipe and they want to implement it, and they prepared a proposal for a deployment voucher, which was already accepted. So they will start implementing this digital twin for preventive maintenance in the next month. And the three main points what we have learned, also what we want to pass, is that for us, this starting with the why and the structures assessment was actually key, and we want to keep on using such a framework whenever we talk to customers about digital twin projects. We also saw that this cradle to grave reflections are extremely important for process digital twins and are sometimes a little bit underestimated in their value. And for other people who want to apply for the deployment voucher, it's actually a very good idea to also do the assessment, because the basis for the deployment voucher are already really good covered when doing a proper assessment of the manufacturing companies. So this brings me to the end of my presentations, and I'm happy to answer any questions if there are any.